We'd have developed a process-based stochastic discrete time series model that simulates spread of a pest or pathogen based on environmental and host conditions. I will quickly walk through how the model works. We start with infested hosts in cell I. Then pests disperse from cell I to cell J. Then those pests find hosts in cell J, and those hosts are now infested. Psi represents the number of hosts that are infested from the pests dispersing from cell I. Now I want to break the model down and examine each process. Let's zoom into the process of pests leaving cell I. So imagine a single infected host in perfect environmental conditions. Beta is the number of dispersing pests from that host under those perfect conditions, but we don't have ideal conditions or a single infected hosts. Often we have multiple infected hosts. In this case, I'm displaying 3. So we modify beta by our environmental conditions and our number of hosts. This gives the total number of pests leaving cell I. Now I'll focus on the dispersal process. Those pests want to find new hosts somewhere, which can be other susceptible hosts in the cell or hosts outside of the cell. Here I show some of them leaving cell I. These pests land in other cells. Then they need to look for suitable hosts within those cells. Here I'm going to focus on those pests that go from I to J and zoom in to the process of susceptible hosts becoming infected. So we have pests that arrive from cell I to cell J. Their survival in the cell depends on environmental conditions and the ease of finding susceptible hosts. If they are successful in finding susceptible hosts, those hosts are now infested. And the number of infested hosts, like I mentioned before, is psi. And now that I've illustrated our model, I want to jump into a video of the GUI running the model and some of the visualizations it's capable of.